Hello, grade 8. Welcome to the chemistry offline class. We are still busy at unit 3 that is entitled as the periodic table. Today we need to study in details the periods of the modern periodic table. It's not anymore related with the initial periodic tables like the one done by Mendeleev, but that is the modern periodic table, the ones that we use in nowadays. Okay, turn your book to page 49. Get ready and let's start. The periods. Periods are horizontal rules found in the periodic table. For example, the horizontal line that can be done between potassium and krypton is called as period. Okay, there are 7 periods. There are 3 short periods, 2 medium periods, and 2 long periods. They are divided in these 3 groups, like short, medium, and long, because of the number of elements that they may contain. For example, the first period is called short because it only has 2 elements. The 7th period is called as long period because it has more elements compared to the first period. Okay, that is why we distinguish between short, medium, and long periods. Let's start with the short periods. There are 3 periods in that group: the first, second, and third periods. There are 2 elements in the first period, 8 elements in the second period, and 8 elements in the third period. The elements in the short periods that they constitute almost 97% of the Earth's crust, oceans, and atmosphere. Helium and neon gases, they occur in trace amounts. What does it mean? It means that the concentration of helium and neon is very small. Okay, they occur in very low concentration. Argon, also a gas, it makes up to 1% of the atmosphere. The other elements are abundant. For example, sodium, potassium, they are abundant. The first period is the smallest period, and you already know why, because it only contains 2 elements. The 2 elements are hydrogen and helium. Hydrogen, it occurs in a diatomic structure. Can you see that we have the subscript 2? It means that hydrogen, it occurs in a diatomic molecule. And then we have helium that occurs in a monoatomic structure. Okay, in the ground state, those 2 elements, they have only s orbital. Okay, there is no p, d, or f orbital in hydrogen or helium, only s orbital. Both helium and hydrogen, they are gaseous state at room temperature. Helium is a chemical inert gas. What does it mean? It means that helium does not react with other elements or with themselves. Okay, itself. Okay, so helium, it doesn't react. It rarely reacts with another element or with itself. That is why we call a chemical inert element. Okay, so helium as a chemical inert element is placed in the noble gas family, although its electron configuration ends up with 1s2. Okay, you will see that the electron configuration for noble gases doesn't end up with s orbital. okay? But then helium is part of this group. But why is that part of this group? Because of its chemical inert characteristics. Hydrogen is placed in group 1, although it shows non-metallic behavior. Okay, we know that group 1, or we will see very soon, that group 1 is for metal. But then hydrogen is placed in group 1, although it has non-metallic properties. The second period, there are 8 elements in this period. Nitrogen, oxygen. Let me start from the beginning. We have lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. Those are the 8 elements for the second period. Nitrogen and oxygen and fluorine, they occur as diatomic molecules in the atmosphere. We have N2, O2, and F2. The diatomic molecule, it means that we have the atoms of oxygen in the air, okay? But then they recombine, and they, instead of being just one atom, they present themselves as two, okay, as a molecule. It's different, for example, from metals or other gases, okay? So diatomic molecules are molecules that they have two atoms, okay? So we have nitrogen gas, oxygen gas, and fluorine. They are diatomic molecules. The gas neon exists as a monatomic structure. Remember that neon is also a noble gas, so it doesn't react with something, with another element, or with itself. That is why it is like a monatomic structure. After helium and hydrogen, neon has the lowest freezing point. Carbon is the basic element of organic chemistry. You're going to learn organic chemistry next year, okay? The fourth period, there are 8 elements in this period. We have sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, and argon. Chlorine occurs again as diatomic molecule in the atmosphere, while argon is just a monatomic element. Sodium, magnesium, and aluminum, they are metal. Let me just point to you: sodium, magnesium, and aluminum, they are metal. In the elements in the periodic, in the third period, also have an s orbital, but they have 3 p orbitals in their valence shell. Okay, so we have s orbital and p orbital for sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, and argon. Can you see? Okay, we have s for sodium and magnesium, but then we have aluminum, there is sp, 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 and so on. Okay, let's try to do this exercise very quickly. It says write down the ground state electron configuration of the following elements. Okay, so we need to write down the ground state electron configuration of phosphorus and phosphide ion. Let me give you 30 seconds to think how we can solve that problem. Okay, your 30 seconds are gone. Let's try to solve that. We need to write down the electron configuration of a phosphorus and the phosphide ion. Remember that phosphorus is part of the third period. Okay, to write the electron configuration, we first need the order of the orbitals. Okay, so let's start with P. You know that if you need to know the orbital, you need to do 1s, 2s, 3s, right? 4s, 5s, and so on. I'm not going to continue, okay, because of time. I have to P, 3p, 4p. Not going to continue because of time. I have 3d, 4d, and then we have 4f. Okay, so we need to write the order of the orbitals. But before we write the order, we need to know what is the atomic number of phosphorus. So if we go to the periodic table, we will find that the atomic number of phosphorus is 15. Okay, so Z is equals to 15. We say that for a neutral atom like phosphorus, the number of protons is the same as the number of electrons. So we also have 15 electrons in phosphorus atom. Now let's write the order. Let's quickly change the color so that you may. Okay, so okay, so we have 1s, 2s, 3, not 3, this, yeah, that is 3p, 3s, no, it's not 3p, I cannot see properly, it's 2, okay, so that is 2p, 3s, 3p, and then 4s. Remember that we have 15 electrons. Okay, we have 15 electrons. So let's try to have the 15 electrons represented. S orbital has 2, S orbital has 2, P orbital can hold 6 electrons, S orbital can hold 2 electrons. So we have 2 plus 2 plus 6 plus 2, that is 12. We still have 3 more electrons to organize. So we have 1s, P is supposed to be 6, but we only have 3 left. So we have that. So the electron configuration of phosphorus will be 1s2, 2s2, 2p6, 3s2, and then 3p3. If we need to use the noble gas, we are going to use neon. Okay, neon is 10. It is 10. If we have 10, it stops here. So we have 3s2 and 3p3. Okay, that is the electron configuration for phosphorus. Now let's do the electron configuration for phosphide ion. That is 3 minus. Okay, so phosphide ion is not a neutral atom anymore. Okay, the charge is -3. So the number of protons is still 15, but the number of electrons will be 15 plus 3. Remember that in case of anion, you need to add the charge to the atomic number. Therefore, we have 18 electrons. Okay, so the electron configuration will be the same 1s, I mean the order 1s, 2s, 2p, 3s, 3p. Okay, I think it's enough. Okay, so if we try to arrange the electrons, we have 2 electrons in s orbital, 2 electrons in 2s orbital, 6 electrons in 2p orbital, 2 electrons in 2s orbital, summing to this 1, 2, 10, 12. Now we have 6 remaining. Okay, so it will be 6. Okay, so that is the difference between the electron configuration of a phosphorus atom and the electron configuration of the phosphide atom. The valence electrons for phosphorus, it will be 3. Okay, so if we have to sum out, will be 2 and 2 plus 3. But for the phosphide ion is not anymore 2 and 3, 2 plus 6. Those are the valence electrons. Okay, so that is what we did. We have the order, the distribution of electrons, and then we have the full electron configuration, the short electron configuration. Please don't forget that that is not a neutral atom, so you need to sum the charge with the atomic number. Okay, so let's go back to the periods. Median periods. The median periods are made by the 4th period and the 5th period. Each of those periods contain 18 elements. The long periods contain the 6th period and the 7th periods. Okay, and the sixth period, it has 32 elements, while the in that 32 elements, only 28 are known. Okay, so there's still 4 elements that needs to be studied. In this period, the 4th period, the valence electrons of the period may be in 4s, 3d, or 4p orbitals. This period, the 4th period, starts with potassium and ends with krypton. Okay, now we are busy with the 4th period. So the 4th period, the elements contain 4s, 3d, and 4p orbitals. The 4th period, it starts with potassium and ends with the noble gas krypton. We can see that we have a branch number of metal elements, and then we have metalloid, and it's finished with non-metal elements. The 5th period is it has 5s, 5p, and 4d orbitals. Okay, we can have a look here. We have 5s orbital, we have 4d orbitals. Okay, let's go to the 6th period. The 6th period starts by filling of the 6s orbitals with cesium and barium. Okay, so we have to fill up the 6s orbitals of cesium and barium.